Hello and welcome back to my channel. Today in this video we are going to discuss few questions from Feb March 2025 970912, that is pure mathematics 1 from Cambridge AS and A level mathematics. So let's start. This is question number 4. The diagram shows a triangle OAB. We can see where OA and OB are same as 10 centimeter and angle AOB is 0.8 radians. Points C and D on OA and OB respectively are such that the arc CD is part of the circle with center O and the radius 6 centimeter. The shaded region is bounded by the arc CD and the line segments CA, AB and BD. So the first part is find the perimeter of the shaded region. So the perimeter we can see here is in the shaded part is the length AB plus BD plus the arc CD plus AC length. Arc length CD is going to be r theta. So radius here is 6 centimeters, so 6 times the angle. Since it is in the radian, that's why it is r theta. Otherwise the arc length was going to be, in the case of degree, it is theta over 360 into 2 pi r. So it is 6 times 0.8 centimeter, which is 6 into 8 is 48. So here it is going to be 4.8 centimeter. And BD, AC and BD, they are same as 4 because the total length was 10 and it is already given, so it is going to be 4 centimeter. And so all we need to calculate is AB. So if we see the triangle AOB, we have the two sides given and one angle given, so we can basically use cosine rule because we have 3 sides involved and one angle. So if I see the pair, I take it as x. So from the cosine rule, this x squared is going to be 10 squared plus 10 squared minus 2 times 10 times 10 times cos of 0.8. So or we can say, since it is going to be a length, so it is going to be just square root of this 100 and 100 200 minus 200 times cosine 0.8. And from the calculator I got it as 7.7883 and so on. So till 3 significant figure, if we write, this is going to be 7.79 centimeter. So finally we can write the perimeter, because perimeter is going to be the sum of all these numbers. So this is going to be 4.8 plus 4.8 is CD, and then BD is 4, then AB we got it as 7.79 plus again 4. So this, if we add them all, we are getting it as 20.59 centimeter, or till 3 significant figure if we write, it is going to be 20.6 centimeter. So that's the perimeter for the shaded region. So here is the B part. Find the area of the shaded region. So for shaded region, the area, we need to find the area of triangle, and then if we subtract the area of sector from that, then we get the area of shaded region. So for the area of triangle, we know the area of triangle formula is half AB sine theta, means the half the product of the two adjacent side and the included angle. So as we can see from the graph, it is half times the sides of the triangles are 10, so 10 times 10 into sine of the angle, which is 0.8 radians, and minus area of sector. So for the area of sector, since the angle is in radians, so it is going to be half r square theta, and the radius for the sector is 6, so it is going to be 6 squared into theta, which is 0.8. So we are going to calculate this from the calculator, either directly, or if we wish to simple cancel out for one more step, that is also fine, but it is acceptable if we write directly everything on the calculator and we calculate it. So it is going to be 36 over 2 is 18 times 0.8, and hence we get this value from the calculator. So this value is 21.4678 and so on. This is correct to 3 significant figure is 21.5 centimeter square. I hope it is clear. Let's discuss the next part. So this is question number 5. An arithmetic progression has a first term 5 and common difference 6. So for arithmetic we have both the informations given. For this progressions, find the sum of all the terms that lies between 150 and 400. So first of all, we are going to find which terms is going to be less than 150, more than 150 and less than 400, and then we'll figure out what that term, and then we can add it. So for the n, we'll calculate the n for which the first term which is going to be more than 150. So for that, and we know the general term is u1 plus n minus 1 into d. So this has to be more than 150. So we know the values of both the parameters u1 and d here. So it is going to be 5 plus n minus 1 into 6. So I write 6 here, greater than 150. So if we simplify this inequality, this is going to be 6 times n minus 1 more than 145 if we send this 5 to the other side, and from here we can get n minus 1 more than 145 over 6, or 145 over 6, or we can say n should be greater than 145 over 6 plus 1. This value is 25.166 and so on. So we need the value of n which is more than that, so obviously it is going to be n equals to 26. So this is the first term. Now we'll find the next term has to be less than 400. So for that I am going to calculate it the same way. It is going to be u1 plus n minus 1. I'll write 5 directly because we know the u1, and then 6 is less than 400, or it is 6 times n minus 1 less than 400 minus 5 is 395, and n minus 1 is less than 395 over 6. N has to be less than 395 over 6 plus 1. 66.8, hence the n should be less than that. So the next value of n is the next term, next is 66, or sorry, less than it is, of course it has to be 66, sorry. And then we need to find the sum. So sum, if we calculate the sum of the numbers, the terms between it, so it's technically, if we see the first term and the 66th term here, and somewhere in between 26th term is coming. So if we calculate the sum of 66th term, that is S66, and we calculate the because we need to calculate, we need to add the 26 also, so we have to include 25 here. If we calculate the first 25 terms, sum of all the terms of first 25 terms, and then we subtract, we get our result. So from here we will calculate S66 minus S25. So this is going to be we have the formula for it, which is n over 2 times 2a plus n minus 1 into d, and that's going to be n over 2 here is going to be 66 over 2 times 2a, that is 2u1, sorry, sometimes we take a as the first term, so 2u1 is 10 plus 65 into because it is n minus 1, so 66 minus 1, that is 65 into d, so that's going to be 390, minus the 25th term, which is 25 over 2 and it is going to be 10 plus 25 minus 1, 24 into 6 is 144. So if we calculate, this is going to be 33 times 400 minus, this is going to be 154. 154 divide by 2 is going to be 77. So 25 into 77, and we can calculate this value directly from the calculator. So this value is coming as 11,275. So that's the sum of all the terms that lies between 150 and 400. Here's the question number 6. The diagram shows a circle C of radius r, where x is greater than 0 and where y is also positive, greater than 0 for all points of on C. Technically they are telling that the circle remains in the first quadrant. The least distance between any point on C and the x-axis is 8 unit. Okay, that's the least distance. And the least distance between any point on C and the y-axis is 5 units. State the, so the command term is state, so we can directly write the answer here. State the coordinates of the center of the circle in terms of r. So we know the least distance is going to be always a perpendicular distance. So if I take the ruler here, we can see that if I drop a perpendicular from here, this is going to give me the x coordinate and the y coordinates of the x coordinates and the y coordinate of the center. So from here we can see I should also draw the horizontal distance. Yeah, so if we see, they are saying that the least distance between any point on C and the x-axis. So we can see that if we choose any other point than this, which is going to be of course the perpendicular distance, it will be more than 8. So this distance, they are saying that this distance and this distance, these two distances are given. So the least distance from the x-axis is 8, so this is 8 unit, and this, the least distance from the y-axis is 5, so this is going to be 5, and we know that this is going to be radii, which are r and r, and hence the center, the coordinates of the center would be r plus 5 for x coordinate and r plus 8 for the y coordinates. So that's the coordinates of the center. I hope it is clear. Let's discuss the next question. And here is the C part. The point on the circle furthest from the origin is denoted by P. Find the gradient of the tangent to the circle at P. So it is going to be somewhere here. I will mark it as point P. This is point P. So if we see the point P, and we know the center has the coordinates as r plus 5 comma r plus 8, and from the previous part we got r as 4, so technically this point become 4 plus 5 9 comma 12. So if we see the gradient of this line, let's say it is gradient of the origin to the point set to the center is m1, and if we draw, because we are finding the gradient of the tangent to the circle at P, so if we draw a tangent at P here, by the rule, by the properties of the circle, we know that this angle is going to be 90 degree, and hence the required gradient would be negative reciprocal of it. So we are going to find the gradient of the line joining these 2 points, origin and the center. So that gradient m1 from here is y2 minus y1 12 minus 0 over x2 minus x1 9 minus 0. So this become 12 over 9, or we can say 4 over 3, and hence the gradient, required gradient is going to be negative 3 over 4. So we, because of the since it is of 2 marks, we can simply say that the gradient of the tangent would be negative reciprocal of the gradient of the line joining center to the origin to the center, because the angle between the radius and the tangent at the point of contact is 90 degree. That would be enough to get the marks. So let's have a next question now. So here's the question number 7. Show that 3 tangent square theta plus 5 sine square theta is equivalent to write 8 sine square theta minus 5 sine power 4 theta over 1 minus sine square theta. So it's better to start with right hand side in this case. So I'll start with right hand side, which I can take out I can factor out sine square theta from the top, because I can see that's common in both. So this can be written as 8 minus 5 sine squared theta over 1 minus sine squared theta. And 1 minus sine squared theta, we know that it is going to be simply cosine squared theta, so we can write it as sine squared theta over cosine squared theta into 8 minus 5 sine squared theta. And sine squared theta over cosine squared theta become tangent, so it is tan squared theta, and in the bracket, now we will simplify the bracket. So this is going to be 8 minus 5 sine squared theta. So we can rewrite 8 also as 3 plus 5, so that I can get the cosine square theta from here. So I'll write the 8 as 3 plus 5 minus 5 sine square theta. So if we can see the identity here, and this can be written as tan square theta times 3 plus, if I factor out 5 again, it is going to be 1 minus sine square theta, or we can rewrite this thing as tan square theta times 3 plus 5 cosine squared theta. So if we'll multiply, and by using the fact that tan square theta is technically sine square theta over cosine square theta, this can be written as 3 tan square theta plus 5 times sine square theta over cosine square theta times cosine square theta. These two will be cancelled out, and we get the left hand side. So that's the proof. I hope it is clear. Let's discuss the second part now. And here is B part. Hence solve the equation 3 tan square theta plus 5 sine square theta equals 9. So since it is the common term is hence, we are going to use the result from the result of the previous part. So from the previous part, we can see that left hand side, which is given as 3 tan square theta plus 5 sine square theta, was 8 sine square theta minus 5 sine power 4 theta over 1 minus sine square theta. So this whole equation got switched to 8 sine square theta minus 5 sine power 4 theta over 1 minus sine squared theta equals 9. Now we need to find the value of theta. So I'll transfer this whole thing to the other side, so that I get an equation, and I can see that it is having only sine square and the sine power 4, so it can be rearranged in the form so that it can be looked as the quadratic in sine squared theta. So I will rewrite this by sending to the other side. It is 8 sine square theta minus 5 sine power 4 theta equals 9 minus 9 sine squared theta. And if I send the left hand side terms to the other side, so this can be written as 5 sine power 4 theta minus 8 sine square theta minus 9 sine square theta plus 9, or we can rewrite again 5 sine squared theta, and this is whole squares, because sine power 4 theta can be written in this form, and it is visible that it is going to be quadratic in sine squared theta. So that's quadratic in sine squared theta. So I can take this, let sine squared sine squared theta be x, or maybe t. I'll take it as t. So this whole equation become 5t squared minus 17t plus 9 equals 0. Now we can directly write the value of t from solving it from the calculator, because you can see it is not possible to use the splitting the middle term or factorization. So I will write the I will use the quadratic formula in this case. So t can be written as, so negative of negative of this b, negative b, which is going to be positive 17 here, plus minus square root of b squared, that is 17 squared, it is 289, minus 4ac, 4 into 5 is 20, 20 into 9, it is 180, over 2 times a, which is just 10. So if I simplify it, it can be written as 17 plus minus root 109 over 10. So if we write these values of t, now I can rewrite this t as sine squared theta. So sine squared theta, I'm going to use the calculator to get this value. Once with positive sign, I think both of them are going to be positive, so like both the values I'll calculate from the calculator here, and it is, yeah, so this is going to be 0.6559 so on, and the other value is 2.7440 and so on. Since sine value, we know the sine is going to be bounded between -1 and 1 inclusively, so sine squared theta will also not cross 1, so we can say that 2.7440 is not possible, so we'll cancel it. It is not possible as more than 1, so we can say from here is sine theta is going to be plus minus square root of the remaining value, which is 0.6559 and so on. I'm going to use the calculator, and calculator has the value 0.6559 and so on, so it's better to get the better approximation. I will actually use the answer key rather than entering into square root of 0.6559 and so on. So I'm putting this in the calculator and I'll get it as 0.809919 and so on. So it is going to be the value. So from here I can get the theta directly by taking arc sine of it. So it is sine inverse of 0.80991 and so on, or theta equals to arc sine, which is sine inverse negative 0.80991 and so on. This value is coming as 54.086 and so on, so 0.86 and so on. So till 1 decimal place, because we are giving the angle, it can be written as 54.1 degree, and we have the theta range for the theta was between 0 and 270 degrees. So the next angle for the value for this is going to be theta equals to 180 minus 54.08 and so on, which is going to be 54.086 and so on. So I can directly write it as anyway 125.913. so till 1 decimal place it is going to be 125.9 degree, and if we'll calculate the next value, we have to add 360 degree, which is going to be cross 270 degrees. So these are the only possible values we can take, and for the negative value, so this is going to be minus negative 54.086 and so on, so negative 54.1 degree. Of course it is below 0, like it is not falling in it's not falling in the range 0 to 270 degree. So we'll calculate the next one, which is not acceptable. So the next one is going to be 180 minus negative 54.1 degree, which is going to be 234.086, means 0.1 degree. So if we see the range, the theta, the answers, solutions are going to be 54.1 degree, 125.9 degrees, and 234.1 degree. So that's the answer. So we'll discuss the next few questions in the next video. Till then, thank you so much.